Hey class, it's Mr. Woodbury, and this is just a little help on that triangle problem at the beginning of project 2. The first one, we're going to walk through the cases of 0, 1, 2, and 3 bisectors and count the triangles. And I'll try to give you an idea for a good way to go at it. Now, when there were 0 bisectors, we just had this one triangle. And so that case was the easy one to count. Below it, I've got 3 triangles that'll show the 3 ways you can have one bisector. And the first place to start is by looking at the individual small triangles. We have one that's over here to the left. We have a second one that's over to the right. And then we have a third one that combines those two together. So when there was one bisector, there are 3 triangles. And the strategy that I'm going to be using is starting with the little triangles and working my way up towards bigger and bigger triangles, triangles that have 2 pieces or 3 or 4. So let's take a look at what happens when there are 2 bisectors. And again, I'm going to start with the case of the small or one piece triangles. And you should be able to notice that there are 3 here. 1, 2, 3. And again, it doesn't have to be a triangle that's not slanted in some way. Like 2 is like what we think of as a perfect triangle. But if you take a look at 1 and 3, they both have 2 sides as well, 3 sides as well. So those are triangles. So far we have 3. Now let's talk about the ones that have 2 pieces. And actually, let me just change the color here. I'll go to purple. So actually, I'll go to the highlighter and I'll start with red. Sorry. So here's one that has 2 pieces to it. Right? There's a piece here and a piece here. And together, they combine to make a triangle. The outside still has 3 sides. Now, if I change the color of the highlighter to green, we can see that there is a second triangle that's made up of 2 triangles here. So we do have 2 of these. We had 3 of that type, 2 of these. Now, when we take a look at the last stage, where we're talking about 3-piece triangles, well, there's only one of those. This one triangle is made up of 3 pieces. So if we take the 3 that we had here, plus the 2 we had here, plus the 1 we had here, that adds up to be 6. Now, you may not be able to see the pattern just yet. It's tough when there's only 3 values. So one thing you might be thinking about is, well, what if I multiply by 3? But then we see that that doesn't work to the second value. Another thing that we can look at is addition. And maybe that will help us with our conjecture. But for now, let me erase this. And we'll move on to the one that had 3 bisectors. And I'm going to use the same approach. I'm going to start with the ones that are made up of the small triangles, the one-piece triangles. And we've got 1, 2, 3, 4 of those. Next, 2 pieces. And this gets a little more challenging. So what I'm going to do is I'm going to draw it and erase it so I can look at the next one. I'm going to start with the one that begins all the way to the left. Over 1, 2. There is one triangle. Then I'm going to move over and start here, move over 1, 2. That's a second triangle. And then I'm going to do it again. I'm going to move over 1, and there's 1, 2, for a total of 3. Right? As we added those up, and I'm going to go ahead and redraw them back in with different colors. So, oops, we had 1 here, 1 to the right of it, and then we had 1 more that used the middle 2 pieces. Anyway, there were 3 of those that we counted as we went, working our way from left to right. Next up, the ones that have 3 pieces. And if we start all the way to the left and we move over 1, 2, 3, there's the first one like that. And then if we move over one spot, there is a second one here. And because now we've reached the end, there's no more that we can do. So there's 2 of those. And then finally, for 4 pieces, there's just 1 like that. So if we add all of these together, 4 plus 3 plus 2 plus 1, that's 10. And we can see that our earlier conjecture still holds true. We added 2, we added 3, we added 4. So you should be able now to come up with how many there would be if there were 4 bisectors. And then to get to 7, which is what the last part of the problem is, you've got to go from 4 to 5, 5 to 6, and 6 to 7. You may be able to come up with a formula for that, but it's not really necessary. You can describe your conjecture, your pattern in your own words. Anyway, I hope this helps you out. If you have questions, you can post them in the discussion board. You can swing by on Monday night's question and answer session, or even send me an email or track me down on Monday during office hours from 2 to 4.